Hello, grade 10. I hope you are all fine and safe. We are going to check the exercises that were given as homework. We are talking about chapter 17, Newton's laws. Book page 195, 196. The first part is test your knowledge. Number 1. State Newton's 3 laws of motion. So the first law is an object at rest stays at rest. An object in motion stays in motion with a constant velocity unless acted upon by an unbalanced force. This is the first law of motion. The second law of motion, the acceleration of an object depends on its mass and the force applied on it. So A equals F divided by M, and the main formula, it's the same formula but another form of it. F equals M times A. We have F and A as vectors because we also have direction included. So the object will accelerate in the direction of the force applied or the net force on it. Third law of motion, for every action there is an equal but opposite reaction. Now, number 2, test your knowledge. Number 2, state Newton's law of universal attraction. So this law says that any two objects attract each other with a gravitational force proportional to the product of their masses and inversely proportional to the square of the distance between them. This is the law. Now, questions. Number 1, true or false, correct the false statements. 1. A particle moves under the action of several forces of zero resultant. It has an acceleration A of the same direction as V. So this statement is false because if the resultant of the force is 0, it means M times A equals to 0, which means that M cannot be equals to 0. M is the mass. It can never be equals to 0. So, of course, A is going to be equal to 0. So, if F equals to 0, then the object is in motion, and it will stay in motion with a constant velocity. And when I have a constant velocity, it means directly that I don't have acceleration. So, A is false. B. Many particles of different masses are acted upon separately by a constant force F. The particle of the smallest mass has the smallest acceleration. Well, if you consider two particles having different masses, if you throw each one with the same force, the smallest one is not going to have the smallest acceleration, of course. It's going to have the highest acceleration because it's inversely proportional to the force. So this is false. F equals M times A. So if you have the same force and M decreases, A should increase. Smallest mass, highest acceleration. Questions 2. Discuss the following argument. In a train, the locomotive exerts on the wagon a force F at a point A, and the wagon exerts at the same point A a force F prime such that F prime equals to minus F. Therefore, the train does not move. So, what's the answer to that? This is false, because though Newton's third law of motion states that for every action there's an equal but opposite reaction, but each one of these two forces is applied on the object by the other. So we are talking here about two objects, each one is applying a force on the other. We're not talking about forces applied on the same object, because in this case the forces will cancel if they are opposite. So which means that these two forces won't cancel and the train might move or might not move, but this doesn't depend on these two forces, the action and reaction forces, because the force always come in pairs. So I will always have an action and a reaction force. 3. The given figure in your book shows the recordings of two motions on an airtable with the same period. What is the type of motion in each case? Explain. So, as you can see in your book, the first recording, we have the same distance covered with the same period of time. So this is a uniform rectilinear motion. Whereas in the second recording, we have different distances with the same period of time. So it's not a uniform rectilinear motion. It's an accelerated motion because the distance is increasing. So with the same period of time, this object is covering more distance each time. So we have an accelerated motion. Number 4. So a car pulls a trolley on a slope. Two spring balances, S1 and S2, connect the car and the trolley. A. The car trolley system is at rest. Do S1 and S2 read the same value? And B. The same question if the system is in motion. So I have a car and I have a trolley. I have two spring balances, S1 and S2. So for A, because the system is at rest, according to Newton's first law of motion, net force is equal to 0. You cannot have a system at rest unless you have net force equals to 0. If net force equals to 0, it doesn't mean that the system is always at rest. But if the net force is at rest, if the object is at rest, it definitely means that net force equal to 0. So S1 and S2 are equal but opposite in direction. Sorry for the spelling mistake. Now, for B, if the system is in motion, will I have S1 equals S2 but in opposite direction? They also read the same value because S1 and S2 are action and reaction force, and they are equal but opposite in direction. So even if the car is pushing the trolley up, S1 and S2 will have the same value because they are action and reaction force. They are in motion. It means there is another force acting on one of them, and it's not related to S1 and S2. Number 5. So true or false, correct the false statements. Yes. So when the forces acting on a body balance, its speed is variable. And the answer is false, because according to Newton's first law of motion, if we have balanced forces, then we'll have a constant velocity, so it cannot change. B. When the forces acting on a body balance, the body stops immediately. You might think this is correct. In fact, this is not correct, because when the forces acting on a body balance, it means F equals to 0, but it doesn't mean that the object should stop moving, because if it was in motion, it will remain in motion with a constant velocity, and if it's at rest, it will stay at rest. This is Newton's first law. Two persons, A of mass ma and B of mass mb less than ma, are standing on an ice rink. A pushes B, who recoils, and B does not move. So is this true or false? False. They both move since no friction forces, and for every action there's a reaction. And D, both person in question C recoil, which is true. They move in opposite direction according to the third law, because for every action there's an opposite, there's an equal but opposite reaction. 6. Choose the correct answer. When a horse pulls a wagon, the force that moves the horse is the force exerted by the wagon on the horse on the wagon, the ground on the horse, or the horse on the ground. And the correct answer is the ground on the horse. When the horse pulls the wagon, it pushes the ground in the backward direction. Due to the third law of motion, the ground exerts a forward force which has the same magnitude. So as the backward force applied by the wagon is weaker than the force applied by the horse, the wagon moves in the forward direction. This is the explanation. Okay. So can you apply the principle of inertia to the following systems? A. A freely falling object. So first, no, because the net force is not equal to 0. This object is falling freely with no starting velocity, but gravity is pulling it down. So the force of gravity is working with no other force to cancel it, so the forces are not balanced. B. A parachutist in a vertical downward motion at constant speed. So since the speed is constant, it means I don't have acceleration. When I don't have acceleration, F equals m times a, so F is going to be equals to 0 as well. So yes, we can apply it here. C. A book at rest on a table. So yes, the book is at rest. It means that the net forces are equal to 0, and the first law of motion applies, which is the inertia principle. A puck moving on a horizontal air table. So it depends if the puck is in a uniform motion or accelerated motion, because if it is in the uniform motion, it means I have a constant velocity, and when I have a constant velocity, it means I don't have acceleration. In this case, yes, we can apply the inertia principle, but if I don't have a uniform motion, I will have acceleration, and if I have acceleration, F equals to ma is not going to be equals to 0, which means I cannot apply the principle of inertia or the first law of motion. I will be then in the second law of motion. So it depends if the puck is an uniform motion or accelerated motion, because if it's a uniform rectilinear motion, then yes, we can apply the inertia principle. But because in this case V will be constant and the acceleration will be null, so net force equals to 0. But if it is an accelerated motion, then no, because V is not going to be constant, and therefore the net force is not going to be equal to 0. 8. Which of Newton's laws applies to each of the following situation? Explain. A. For the same force of traction exerted by the engine of a car accelerating from 0 to 20 kilometers per hour, it takes longer time when the car carries 4 passengers than when it carries only 2. So for this statement or this situation, I have same force of traction. I have 4 passengers in one case and I have 2 passengers in the other case. So the mass is changing. So I have different accelerations. Newton's second law of motion states that F equals m times a. So since F is constant and m decreases, a should increase. And if m increases, a should decrease. B. A hunter has experienced a sore pain shoulder after firing a shotgun. So, Newton's third law of motion states that I have action and reaction law. So, forces always come in pair. The shotgun fires and hits the shoulder back. This is the reaction force. C. It is almost impossible to stop a car on a hard, smooth ice. Here I have Newton's first law of motion. The inertia of the car, it means how hard it is to change the motion of this car or this object. So I have the car will keep on moving because no forces are applied on it. So in this case I have the first law of motion. And that's it. Thank you very much, grade 10.